Well, technology is on the uptick. Of course, we all know that, right? Who thinks of this stuff? Wow. You know, we can always talk about younger days and whatever. Yeah. This is just really some amazing, these are some amazing things that people, the areas that people are thinking in engineering and moving forward into the new era, as I call it. The largest, exponentially largest era of opportunity I've known in my lifetime. Uh, Outside of my lifetime, the largest era of opportunity I've known in any history that I'm aware of, other than the Industrial Revolution, which took people off the farms and put them in the tenant homes and made them virtually robots, but it was for the sake of humanity, right? But with solid electrolytes are neither volatile nor flammable, unlike the liquid electrolytes used in conventional lithium ion batteries. I'm talking about lithium air battery design poised to increase energy, storage, and EV range. That is crazy. Someone's a genius. Liquid air. And I saw that there's also a saltwater battery. Saltwater battery that uses virtually no power and creates an incredible amount of energy. We'll have to check on that one. Let me get a water. Excuse the noise. And here we go back. Discovery of a new lithium ion, a new lithium air battery that can store much more energy per volume of battery than today's lithium ion designs has commercialized a radically extended view of how the electric vehicle will perform and its range, and it will significantly reduce the weight and the size of the battery, which helps with mileage within itself. Given the important role lithium ion batteries play in the modern world, researchers are continually trying to develop safer and more energy efficient methods. But in a recently published paper, key insights into solid electrolytes were tested and using a solid state battery, and the results were actually, uh, in the results they actually found that the solid state battery was still ahead of its game, but not as efficient as the lithium air battery. So they decided to go ahead and give that a shot. And that's where we are today in technology as far as the EVs go. And there's an emerging they're emerging as a critical technology for the future development of lightweight, energy dense, longer lasting, and safer lithium ion batteries. I guess they're saying with them being lithium air, they're not as combustible. This design could radically extend the driving range of electric vehicles while significantly reducing battery weight and size. Of course, I've said that. I think that's the third time. But I'm looking at how it's built. I'm no engineer of any sort, but yeah, it's different from any other battery I've seen. And it has an embedded matrix made of material called ceramic polyethylene oxide polymer. So for you scientific people, you know what it is. So going on, it says this solid state air battery is the first to achieve a 4 electron chemical reaction at room temperature. In our 4 electron chemical reaction, 4 electrons are transferred between two chemical species. This type of reaction, although common in various states, such as electrochemistry, is a feature or it actually is a feat never before accomplished in a lithium air battery operating at room temperature. So most lithium reactions involve one or two electrons. So a key element in this chemistry is a powerful catalyst called wow, MO3P. Trimolybdenum, wow, MO3P. MO3P, trimolybdenum, MO3P, trimolybdenum phosphide, MO3P. This catalyst facilitates the critical 4-electron transfer while ensuring the reaction remains stable over long-term use. With the development, the researchers said their lithium air design could reach a record energy density of 1200 WH/kg. I apologize. I should know what that is. The next time I will. The density is 4 times greater than can be found at today's lithium ion batteries. What is LLZO? What is LLZO? Something else I probably can't pronounce, but here we go. LLZO is the study showed that a solid the study showed that a solid electrolyte made of lithium, lanthanum, zirconium, garnet, LLZO, bam. Or for those in the audience with a degree in chemistry, it's lithium 7, lanthanum 3, zirconium 2, garnet 012. Okay. What's the best candidate for such a battery? So LLZO is the best candidate for a lithium air battery. Or let's just say, since we know that O12 and the O in the periodic table is oxygen, 12 parts oxygen. So we'll just start calling this, for the sake of betterness, a lithium oxygen battery. Excuse me. This material stands out because of its strength and durability. It's also notable for its conductivity, or the ease for which it moves lithium ions between electrodes during charge and discharge. Just as if gold is far much more better conductor in wiring than aluminum or copper. Okay, but gold is actually has a lower melt point, so it's not normally used in high voltage. It's mostly used in electronics. That's what I know. So in the study, researchers examined what happens when LLZO containing aluminum or gallium dopants contacts metallic lithium, and understanding this is what makes it understanding what makes it behave differently depending on which dopant has been added will help scientists design better materials for stable and reliable solid-state batteries. Guys, this article is longer than I thought, and I'm not an expert, but in conclusion, in this case, the researchers were able to measure key properties of the doped materials. At the same time, they gained an atomic level insight on what was happening at the interface between the lithium metal and solid electrolyte. Using a powerful computer-based method known as density functional theory, a quantum mechanical modeling method of study on how atoms and electrons behave in materials, the researchers were able to predict that stability and various dopants and how they would react with other substances actually was relevant. So the lithium air battery has the highest projected energy storage density of any technology being considered today. And we're hoping that they're successful with this, because what we need is the best that we can possibly offer, the safest that we can possibly offer, and the most friendly to the environment products that are out there, right? That's what we all strive for. You know, we want technology to advance us, but we also want to make sure that we're able to not harm the environment as much as possible. So this would dramatically increase how much energy batteries can store using a solid state electrolyte instead of a liquid electrolyte. Would also dramatically reduce safety concerns due to fire. I think I mentioned that before they said that. So y'all give me some credit. I'm not an engineer, but I kind of know something, or at least one thing, or two things, because I know oxygen is not, or oxygen is in the battery. Therefore, we may be able to call it a lithium oxygen battery. And I also know how to pronounce LLZO, although I don't know how to pronounce MO3P, trimolybdenum phosphide. Stay tuned for the next one. Thanks for watching. And if you haven't done it today, tell someone you love them. Be kind to yourself and be kind to others.